In 1993, Roger Pedersen, an amateur archaeologist, discovered something unusual in a gravel pit in Sussex.
Since it was Friday, I had to be quite careful that I didn't start finding things that would need particular attention, because I have to go home for the weekend at 4 o'clock. I was actually digging in a trench when I found that there was a bone. I knew that there was something unusual about it, and I was trying to think what it could possibly be. But I was looking forward to a weekend at home anyway.
At 500,000 years old, Boxgrove man stands tall among archaeology's greatest finds. Here, archaeologists have discovered a human bone in a Sussex quarry dating back 500,000 years. It could be the oldest find of human remains unearthed in Europe.
Studies on the human fossil will take many months. Scientists now hope the Boxgrove site will reveal further evidence of man's early ancestors.
The discovery was the opening chapter in a detective story. Who was this human ancestor whose remains had been unearthed after so long? What did he look like? When did he die? In the spring of 1995, the archaeologists went back to the site to try to solve the puzzle of Boxgrove man. They were led by archaeologist Mark Roberts.
Frank, can you come down? Sit down there. Sit down.
Boxgrove is a very important site. Even before the hominid was found, archaeologically it was very significant, because you've got stone tools, you've got animal remains being found in a virtually undisturbed context, as virtually as they were left 500,000 years ago.
You don't get many sites like this with such good quality of material, and the fact that it's very fine sediments means that everything is pretty much where it was dropped, where it was left, and that's almost unique.
I would like to be standing here holding a piece of the skull of Boxgrove man. I won't be greedy. I won't say I'd like to find the whole of the skull of Boxgrove man. A piece of the frontal bone of the skull of Boxgrove man would do me very nicely, and hopefully the remains of about 6 of his relatives as well.
London's Natural History Museum is now the guardian of the bone that made Boxgrove famous.
This is the tibia that was found at Boxgrove. It's very complete in the shaft region. It's missing the ends, but there's enough there to give us some important information about the owner of this bone. The sorts of questions we would hope to get from a bone like this are things like body size. How heavy was this individual? That's important if we're looking at considerations of brain size versus body size. We also would hope to get a picture of the body proportions. What kind of body shape did this person have? Because in modern people, people who live in cold conditions are differently shaped from people who live in warm conditions.
In Sussex, the quest was on to unearth more fossils. For Mark Roberts, the site is a window into prehistoric life.
I'm particularly interested in what people are doing. We've spent a long time looking at the flints, looking at the bone, measuring them, looking at the species, etc., etc. But the real thing that I want to be able to do is be able to present concrete sort of evidence for different facets of human behaviour in this period.
Any discovery, however small, could be a vital clue, so everything found was meticulously recorded. Almost at once, Boxgrove began to yield up secrets in the form of scores of flint tools,
This is fairly common, I think, for the hand axes here. At least the ones I've seen. Somebody knew what they were doing when they made this thing.
I'd like you to hand it to me, please, in a ceremonial fashion. Thank you, man. Beautiful piece. Yeah. Chuck it in a box.
They're certainly not just found at Boxgrove. They're found all over the sort of western half of the old world. Africa, the Middle East, Western Asia and Europe. And of course one of the big mysteries is what were these being used for? They have a lifespan of over 1 million years and they're found in different environments with different kinds of hominids. So what are these stone tools being used for? And Boxgrove obviously can help us answer questions like that.
To solve the mystery of the flint tools, the archaeologists experimented with making their own.
Usually start off using the pebble and then you can sort of bring in the soft hammer, which is the antler. And there's no actual direct evidence of them using antler at Boxgrove, but there's a lot of direct archaeological evidence that they were using bone. You see that's worked pretty well. You can see there where the flakes come off across the tip. It's basically got everything you need. It's a handle. This whole thing is a handle, and although it's sort of sinuous and occasionally has sharp bits around the edge, you can actually hold on to it firmly. It gives you a good grip. Secondly, it's got like this sharp, very sharp tip, and that you could use for cutting anything. You could cut into skin, quite thick skin.
From all over the world, scientists came to ponder the mysteries of the fossil shin.
Put the pieces together. No, it helps if I get it the right way around. Okay, here's Boxgrove, and when we look at this and...
Eric Trinkus from New Mexico came to investigate how the Boxgrove shin relates to other fossil limb bones from the Pleistocene, the scientific term for the last 2 million years.
And it's really much more robust than this probably much more similar length specimen from Goff's Cave, from the Mesolithic of Goff's Cave. But what's really interesting is that if you compare it to the Broken Hill specimen, which may very well be as old as Boxgrove, but from equatorial Africa, Broken Hill's a little bit longer, not much longer, but it's not nearly as heavily built as Boxgrove. And this probably has something to do with body proportions.
With only a shin bone, Trinkus had very little to go on. To squeeze every ounce of significance from it, he resorted to high-tech medical technology, the body scanner at University College Hospital.
Set up a little guy here. Okay, and I need to prop them up. We can see a really nice clean cross-section here of the tibia with the outside border very clear. What we already see is a bone that is very thick, especially anteriorly, which is on this side, and moderately so across the posterior part. The most important thing that we can do with the CT data is to calculate accurate measures of the amount and distribution of bone in cross-sections of the shaft of the bone. These are measurements that mechanics use or mechanical engineers use to measure the strength of structural materials in bridges and buildings and the like.
Trinkus turned the scan data into graphs that related the length of the tibia to its strength. He was surprised to discover that Boxgrove man looked even more heavily built than the Neanderthals, who were the incredible hulks of prehistory.
What we get, first of all, is a line of relatively robust individuals that includes early modern humans and also includes the tropical Middle Pleistocene specimens that we have from Indonesia and from Africa. However, above that line, we have another line of what appear to be more robust individuals, which are the Neanderthals. And this is just when we're comparing the shaft strength to the length of the tibia itself. When we put Boxgrove on that, we add it into the plot, it falls very high up, right on the line for the more robust Neanderthals.
Boxgrove man looked impossibly robust. The solution lay in body shape. All over the world, people have been moulded by climate. Near the equator, they're tall and thin, so that heat can be easily dissipated. But nearer the poles, bodies are squatter, so their owners can conserve heat. What shape was Boxgrove man?
When we give him an equatorial body shape, the tibia comes out being extremely robust, exceptionally so, at such a high level that it's very unlikely that this is realistic. If we give him an Arctic body shape like the Neanderthals, what we end up with is a point that falls right on the line for the other Pleistocene humans. Robust, quite robust, but perfectly real.
With Boxgrove man's vital statistics pinned down, the fossil could be linked to other discoveries in Europe and given a scientific name, Homo heidelbergensis.
In Europe, we haven't got a tibia that's as complete as the one from Boxgrove to compare with. In fact, we've really got nothing else of this age in Europe to compare with in terms of the tibia. But we've got other parts of the skeleton which at least show a comparable degree of robusticity, of bodily strength, and of the same age. And the most important one, of course, is this jawbone from Germany, from Mauer, the Heidelberg jaw, which is the type of this species, Homo heidelbergensis, that we provisionally assigned the Boxgrove individual to. We've also got a skull from Greece, maybe a bit younger in age, from Petrolona. This gives us some idea of the form of the skull that we would hope to find at Boxgrove. We've got other materials such as this pelvis from France, from Arago. And so these form a set which, together with material from Africa, probably give us an idea of what the likely overall form of the body of the Boxgrove individual was.
By scanning the fossil measurements into a computer, Boxgrove man was brought back to life. Trinkus's work suggested that Boxgrove man was a link between tall, early humans and the massive Neanderthals who were designed to withstand cold climates. But to flesh out the fossil evidence, the archaeologists needed to come up with an important piece of information.
Right, let's go.
The issue is simple. How old is the Boxgrove site? The answer is crucial to how Boxgrove man fits in the pattern of human evolution. But getting an answer turned out to be tricky. The first clues were in the sequence of geological strata.
We're at the very base of our geology here, and we're stood on the solid chalk, which goes down for 1 kilometre beneath me. The sea came in, cut into the chalk downs, created this wave-cut platform, and a cliff at the back of the site, which is about 40 metres to the north of us. Parts of the cliff are collapsing through time, and here we see this chalk block which has come off the cliff and then been sculpted by the sea. As I go up this ladder, I'm going forward through time. So when we reach here, we're at the end of the marine sand phase, so that's the end of the open shore face with the sea coming into the cliff. We then go up into these deposits, which are silts and clays, and we could call these a mud. The archaeology has found at the base of the muds, at the interface between the sands and the muds, and within the body of the muds themselves. Now, by the time we get to the top of the muds here, the sea has disappeared altogether, and we very quickly get the build-up of a soil in and on the surface of the muds, vegetation, grasses, etc. And we estimate that that lasted for about 100 years. Now, when we get up into here and these deposits above that, we're looking at the beginning of climatic deterioration, and we're going from the warm interglacial into the cold glacial, and by the time we're sort of halfway up that top part of the section, things have gone cold and we flipped over into the next glaciation.
That cold period was the result of the arrival of glaciers in the British Isles. It should have provided the next dating clue. But at Boxgrove, there's a problem.
We want to know what was the glaciation overlying it, because that will tell us the age of the site. But because Boxgrove is right on the south coast of England, south of the margin of all the ice sheets, we haven't got the thick glacial deposits that are very diagnostic that would tell us exactly which interglacial it was sitting on top. We've got cold stage deposits on top, but they don't tell us which glaciation it was. That's the problem, really.
The archaeologists had a secret weapon.
This is a sieving machine, and the purpose of this machine is to put in dried sediment, which is then sieved through 1 centimetre and 500 micron meshes, and we collect the residue, and then from the residue we pick out the remains of small mammals like voles and shrews and mice, and then we analyse those back at the lab.
With each glaciation, there was a turnover of mammal species. Some of them became extinct and never came back in the following interglacial. Some of them had evolved into something different. So we've managed to identify a pretty diagnostic set of fossil mammal species, or evolutionary levels, which you find in each interglacial.
Hi Art, latest sample.
Oh, great. I've just finished that one,
Yeah.
so let's have a look at this.
Right, I see at least one water vole in there.
Some large bits of flint.
Yeah, there's a lot. It needs to go through the
Bone
sieves, I think.
fragments.
Animal species change over time. So by pinpointing evolutionary events, the Boxgrove archaeologists could work out the age of the site. They call it the vole clock.
Quite a few water voles in here.
It's a group of mammals which are evolving very rapidly. As the grasslands expanded at the beginning of the Pleistocene period, these animals have evolved to fill that niche. They're really the small grazers in these habitats. Originally they start off with quite low-crowned, bumpy teeth, and then throughout the evolution of very many of these lineages, the teeth become higher-crowned, like these forms here. You can see the sides of the teeth are quite straight, and also continuously growing, so those are two changes in the teeth that are happening in tandem.
When all the evidence was put together, a pattern emerged. Voles evolve different teeth, while shrews and other mammals thrive, then disappear. These are the fingerprints of the Cromerian interglacial, a warm period which ended with the arrival of glaciers 500,000 years ago. So if Boxgrove man belongs here, in the Cromerian, as the fossil evidence suggested, he must be at least 500,000 years old. That date strongly supported the idea that Boxgrove man was ancestral to the Neanderthals, who evolved much later, after the glaciation. The problem is that not everyone believes the vole clock. David Bowen, a geologist at the University of Wales, has developed a new dating method using fossil snails. And his mollusk clock surprised everyone.
The method relies on protein that is contained in living shells and in fossil shells. Protein consists of strings of amino acids, and the amino acids can exist in two quite different forms. In a living organism, there are L forms, best thought of as left-handed forms. Once that organism dies, once that shell dies, the L amino acids change over time to D amino acids, easily thought of as right-handed forms. And these two forms are non-superimposable, they're quite distinct. The number of D amino acids builds up over time until there is an equilibrium. That is to say, there's an equal number of L amino acids and D amino acids in the fossil. And this takes about 1 million years. So we have at our disposal a geological clock that's running for 1 million years. It's fully sprung when the organism dies.
This year, Bowen analysed fossil mollusks from Boxgrove.
we discovered that the amino acid clock had run for 30% of the time. And in comparison with sites elsewhere in the British Isles and in comparison with other dating methods, that gave us an age of 400,000 years, which is a full ice age younger than the claim for 500,000 years.
A younger date for Boxgrove meant there could be no simple line of descent to the Neanderthals.
Swanscombe site in Kent has got a human skull, or the back half of a human skull, which seems to show Neanderthal features, and this would be one of the earliest examples of the Neanderthals if it really is dated at around 400,000 years old, after the Anglian glaciation. Now, if Boxgrove moves younger, to the same sort of age as Swanscombe, then, well, I think it would pose some interesting questions in terms of who was living in Britain during that interglacial, because we'd have heidelbergensis, at least on the taxonomy I'm proposing, down in Sussex, and in Kent we'd have Homo neanderthalensis. So it would certainly make things more complicated, and we'd have to rethink this question of taxonomy in that period around 400,000 years ago.
Thijs van Kolfschotten and Will Robrox have looked at the fossil evidence all over Europe. Horizon invited them to the Natural History Museum to check the material from Boxgrove and arbitrate on the conflicting dates.
So most of the material is at the site now, or?
The new materials on site, and here we're housing the old collections. The small mammals are over here, and the large mammals are stored in this cabinet. Let's look at this drawer to start with. This is fairly typical of the type. Very well preserved.
But it means that you spoke about 10,000 fragments, that you have an awful lot of fragments you can't identify, or it's identifiable fragments?
That's right, that's 10,000 identifiable fragments. We can identify those to species.
Oh, that's great. Yeah. Really marvelous site because of the amount of information which is available in this small area. It's incredible.
Every site is unique, but this is unique with a capital U. Nice legs, Robert.
Yeah, they're good leg for an old man. How you doing?
Fine.
See you,
Hey,
Thijs.
nice to meet you.
Hi, Art.
Okay.
Good trip.
From the fossil evidence, the Dutch scientists were certain that the older date is the right one.
One of the problems with amino acid is that it's to a high degree dependent on estimates of former temperatures, and whether you're talking about a 300,000 or a 500,000 year site, it's difficult to estimate the temperature history of the samples that are being dated. So that's one of the big uncertainties of that method.
For me, there is no question about it. It's if you look at the faunal evidence, then it's clear all these fauna remains which are indicative for a late Cromerian age.
The Vole clock is simply based on comparing the species assemblage at one site with another site, and to that extent it must be regarded as qualitative. It's artistic impression, if you like, compared with numerical accuracy.
If you could imagine being dropped in the middle of an unknown continent with some kind of a machine that gave you a number to tell you where you were in the world, and you looked out of the window and saw kangaroos and wallabies jumping around, but the machine told you were in Africa, you wouldn't believe it. You'd believe you were in Australia. You'd believe the faunal evidence and think there's something wrong with the machine.
I'm giving a lecture as part of the Chichester festivities, whose theme this year is Chichester City of Culture. They laugh. And I'm going to prepare a shave, catch up with the day's events, and I'm going to prepare my lecture in half an hour. And I'm going to be there at 20 to 6. Roll along. Go one step further down the road to the coronary. Right, turn that thing off and let's get out of here.
By July, the archaeologists were enduring the hottest English summer on record, and they had begun to uncover remarkable evidence of how Boxgrove man had spent his time 500,000 years ago.
long axis is at 282 degrees.
The sheer numbers of tools at this level are unlike anything we've experienced before. The material here is in such good condition and has not been subject to movement or battering with other pieces in the ground, and therefore you can pick out edge damage along the sides of flakes. And we have flakes here that are edge damaged through use.
There was more. Alongside the flint tools were scattered the bones and teeth of a large mammal.
There's a fever. Because we made him decide. We made him say right on the spot what it was.
He actually gave you an answer on the spot there and then.
Well, first
That's
Mark
brilliant.
came down and said Rhinoceros etruscus afarensis and said that it has to be rhino.
The rhinoceros turned out to be the most important discovery of the summer. The reason was that its bones and the flint axes had not ended up together by accident. Under the microscope, the bones revealed scratch marks. They had been scraped by something sharp. Others revealed telltale pieces of flint embedded in the surface of the bone. For Mark Roberts, this was good evidence for what had happened to the rhinoceros 500,000 years ago.
This find is very important because on this surface we have a rhinoceros that has been butchered, systematically butchered, and was secured probably as a whole carcass and maybe even killed by these people. If this rhinoceros was hunted in an open environment, that would require a degree, I think, of social organisation and cooperation that again is not normally attributed to these Middle Pleistocene people.
Yeah. Digging there sometimes. That's right.
Right, if I paint the background to what we've done in here this year, the original trench edge of...
Roberts was keen to show off the new finds, above all to the steering committee who have the job of checking up on progress at the site.
There's a dozen like that. You look at these and they've still got...
An important member of the steering committee is archaeologist Clive Gamble.
That little tranche, just that one you showed us there with one on either side and so on. I mean,
His interpretation of the evidence is that Boxgrove Man was an opportunist scavenger, not a big game hunter. He simply wasn't smart enough.
It's not heavy enough, but you could do it. You could knock off a great big flake off that. I mean, look at that one. Look at that one.
No good.
Now, whether Boxgrove Man had that sort of anticipation, I rather doubt. I still think they were fairly sophisticated, but, my scenario would be that they're walking along the cliff here, and they're looking down onto this area, and they see animals there for the taking, whether they're going to kill them or whether they're going to pick them up because carnivores haven't got to them yet. And so they shimmy down the cliff, they pick up the piece of flint on the way. They rush out here because this is quite a dangerous area for them, because we are dealing with lions and hyenas and wolves and so on. There are some nasty things out there. It's that sense of planning. That's the difference with the hunting as opposed perhaps to the scavenging, is that planning and anticipation and moving around the landscape.
But was Gamble's view of Boxgrove Man supported by the latest discoveries? Peter Wheeler suspects that the flint tools and butchered animal bones demand a different interpretation. Wheeler thinks that what Boxgrove Man was putting in his stomach is evidence for what he had inside his head. At Boxgrove, he joined in an experiment to find out whether flint tools really are up to the job of dismembering a dead animal.
Diet has major implications for the evolution of one of the most important human features, which is our large complex brains. Now, brains are very energetically expensive organs. In fact, an average human brain is using about as much energy as a 20-watt light bulb. And you might expect, therefore, that an animal such as ourselves with a very large brain would have a higher than average total energy requirement. But what we found is that isn't the case. The energy requirements of a human are more or less exactly those you'd expect for a typical mammal of our body size. But interestingly, our brains are about 1 kilogram bigger than you'd predict, and that is almost exactly counterbalanced by the guts being 1 kilogram too small. So we've got larger than average brains counterbalanced by smaller than average guts.
How's that hand axe holding up?
Okay. So it's not actually being used as a hitting implement, it's actually more a steady pressure with a sawing action that's actually doing all the cutting.
Yeah.
Do you ever find thin fragments of the actual flint itself embedded in the bone, where the edges are broken off as a cut's been made?
We've got some red deer limb bones with those little traces of flint along the edge.
Right.
In the cut mark.
The carcasses that are being processed at Boxgrove contain a lot of very energy-rich food. But interestingly, we're seeing the bones being smashed, presumably to get at the marrow, again a very rich source of nutrition, another very high-quality food. So these humans are systematically taking apart these carcasses and potentially extracting very large amounts of very high-quality foods from them.
The experiment showed conclusively that the flint axe was a superb butchery tool. But for Wheeler, there were other implications.
To digest a fairly low-quality diet containing large amounts of poor-quality plant foods, you need a very large digestive tract. When the brain first starts to increase in size, that's when we're moving to a higher quality diet or starting to incorporate more animal products into the diet, and that's enabling us to evolve smaller guts. And that smaller gut size, if you like, is paying for energetically the increase in brain size that we're seeing.
The rhinoceros bones revealed even more. The scratch marks were beneath and therefore made earlier than tooth marks made by other predators. So Boxgrove man must have got to the carcass first.
So there's a lot of people around the carcass doing things, chopping it up, defleshing it, splitting the bones to extract the marrow, and there doesn't seem to be anything in that process that suggests haste. It's all very methodically done. That implies to me that they actually didn't have any problem securing carcasses within the landscape from other major predators.
And what would have been the main threats around in the area at the time?
We got a leopard, lions and hyenas.
So if Boxgrove man had got first pickings, could that imply that he had also hunted and killed the animal? It's a question that divides paleontologists.
The view maybe 20 years ago was that these people were probably capable big game hunters. And then within the last 10 years, the pendulum swung the other way to the view that, in fact, no, they were probably lousy hunters and maybe they could catch something the size of a rabbit now and again. But otherwise, they were mainly scavenging. They were having to get secondary access to the kills of other carnivores. So they were not capable hunters. And now, of course, sites like Boxgrove are giving us new data that's kind of opening up the whole debate again.
It was Britain's leading forensic pathologist Bernard Knight who resolved the debate. When he was shown a find from the Boxgrove site, the shoulder blade of a horse, he discovered incriminating evidence.
I'm often asked to look at bones and pictures of bones. I must admit at first I wasn't all that impressed, though there was this very regular, almost semicircular defect in the edge. Then I went up to the Natural History Museum and looked at the actual bone. And I must say my scepticism was reversed quite remarkably. First of all, there was this quite impressive, I suppose a third, almost half a circle cut out very regularly. But the main thing was, if you looked end on at the defect, and if that's the top of the bone, there's the outside, facing the outside world, so to speak, there was at the edge of this defect a cliff and then a chamfered, tapered off edge there. And this is the important part, because if that's the other edge of it, if an impact comes that way, the top edge is cleanly cut. There's a clean hole there, but as this is not supported, a piece of bone breaks off and you get this terraced effect on each edge. You see this in bullet wounds through bones or any moderately high-speed impact. And that to me is absolute proof that this must have been something going fairly fast and hitting one side and going through to the other.
Could it have been a spear, hurled by Boxgrove man, the hunter?
Right, so that's it then. So, one horse scapula, and we're set up. And if we just bring that down and make sure that we're actually in... Yeah. Okay, so
the archaeologists turned to Bernard Knight's forensic laboratory to find out. This machine mimics the effects of projectiles, in this case, a wooden spear.
It's just a matter of seeing whether it's actually going to go through. Moment of truth. Ah! That's a very neat little hole. It's an excellent start to the experiments. We've shown that the spear tip's going to go through, and it looks as though we will be able to almost exactly replicate the wound that we found on the original Boxgrove scapula.
At the beginning of autumn, another discovery provided more evidence about Boxgrove man's way of life, and exactly when he was at large in Britain.
This is a shed antler of a giant deer. Not absolutely certain which particular species of giant deer it is at the moment. One thing I do know is that it's not a form called Giganteus. I can tell that by the position of the tine, which is the later period of giant deer that we find from sites like Swanscombe. So it's an early form, which is what I was hoping for.
I was very excited when Mark Roberts rang me up one day and told me he'd found this antler, and even from his description over the phone, I thought it was probably a species which we call Megaloceros dawkinsi. This specimen from Boxgrove compares extremely closely with this one, which is from the Cromer forest bed in Norfolk. And you can see particularly that in the lower part of the antler there is absolutely no branch there at all. Instead we have this ridge leading up to a branch much higher up. And you can see exactly those features in the Boxgrove antler. Absolutely no branch at the bottom whatever. So this is a species of giant deer which we only know from the Cromerian complex. It's absent from all sites after the Anglian. It became extinct in the Anglian glaciation.
If the antler was from a time before the glaciers, it was definitive proof that the site was at least 500,000 years old.
The critical thing now is to get this under the microscope, because if it follows the pattern of the bone hammers, it'll have pieces of flint embedded in this face, and that's what we've got to find out next. If it is, and I'm 99% certain that is an antler hammer, this is the oldest antler tool in the world, so this is a big find.
The way the antler hammer had been repeatedly used implied that Boxgrove man wasn't the thoughtless opportunist imagined by Clive Gamble.
For example, last week's discovery of this antler hammer.
Right.
Now, one of the great things that is always quoted about people, Middle Pleistocene hominids, is that there was a lack of curation.
Yeah, now what do you mean by that?
Well, the fact that you have a tool and you keep that tool over a long period of time, and that tool is something that you carry about with you because it is important to you. When we put this under our microscope, you can actually see the chips of flint embedded in that surface there. And so, I mean, that is what we have waited for sort of 7 or 8 years. I mean, people have replicated experiments always using antler, and we've always assumed it, but now, at long last, we have it, the antler hammer.
It does make them look a lot more like Boy Scouts in terms of being prepared, that they're setting off. This is, you know, an item of personal equipment. They're out there. When they need stone, then they can quickly nap it into those particular forms. What it shows is very clearly, from what we found this year, is that they were killing animals, that they were processing them very efficiently. They'd really got the food side of life sorted out. And it's the size of the animals that they were taking, which is also part of that impressive character, the rhino, the horses, the big deer, and so on. All of that side, the sort of technical, routine side of life, they do seem to have got very well sorted out.
I think this year's work has been marvellous. I think it's been more, on the archaeology side, I think it's been much more rewarding than I would have expected. The number of artefacts being found, the context in which they're being found is fantastic. On the hominid side, well, it's disappointing not to have found some more of the skeleton of the individual that we had, but on the other hand, this lower level, which is even richer, I think still has tremendous promise.
Stringer's hunch was right. Just as the dig began to wind down, something rather interesting turned up.
It was Wednesday morning, and it was really nice and hot. I was troweling as normal, and the tooth just popped up. And I remember trying to think how it had come out of the ground, but it definitely came out with the root upwards. And it crossed my mind that it was hominid, but you know, there's only been one tibia, and I'd found deer teeth that day, so I thought it was just another deer tooth.
It's the 25th of August. We're on our way, it's 4:30. We're on our way to the Natural History Museum in Kensington, South Kensington, with a little tooth in our bag. And we think it may be Boxgrove hominid 2, found by lovely Laura a couple of days ago. So here we are, South Kensington.
Here we are, South Ken.
Yeah.
Natural History Museum.
And there we have it. The Victoria Natural History Museum.
It's the central incisor. You can see the crown, the root, and the only damage is this break here at the tip of the root. And that's an ancient break. The crown is very worn, so we can tell that it's from an old individual, an old adult. And the other interesting thing that we noticed when we were looking at it was this pathology. There's calculus around the base of the crown, this deposit here, which is a tartar deposit. It doesn't look much, but it can provide us with an immense amount of information about the individual, this single find. It's very important.
The tooth made Boxgrove world famous all over again.
Carl Smith, they'll give you a package.
The purpose of the project is to investigate the origin of the human species in the United Kingdom and therefore in Europe and indeed on a worldwide scale. And there is no more important study than the study of where we all come from and what has made us what we are today.
Teeth come in sets of 32, so I think with the preservation of bone in this level that there's a very good chance there'll be more teeth and hopefully the jaw it came from.
Right, let's go.
A whole tooth marked a triumphant end to the dig, but more important was the secure date for the site. A treasure trove of flints and animal bones, and a clearer picture of the life and times of the Butchers of Boxgrove.
If you were working, wouldn't you be kneeling or anything? It looks a bit uncomfortable as you're sitting at the moment. How was your colleague working there? That's it. That's it, a bit more natural.
Basically.
Okay, now, just sit up a bit more upright. That's it with your cool words.
That's lovely.
Yes, this is a second individual. It could be a female. We can't say that from a tooth, but it's a second individual definitely.
Laura, can you just turn just very slightly more? That's fine. I'll frame it the other way and then we.
Okay. He's up there with Channel 4 at the moment.
Oh, I see him. Yeah.
So much
Sorry.
What about the reaction of other people?
Everyone went mad, absolutely. Lots of champagne.